Leading AI providers are covertly reducing model performance to manage the rising costs of compute. Instead of scaling massive, single, linear engines, the industry is now splitting these workloads into parallel networks and self-managing agents. As the reliance on simple chatbots decreases, technical advantage is increasingly found in automated agent infrastructure. This line graph shows the decline in Claude's thinking depth over the last 2 months. Research from an AMD director found that the AI now reads code twice before editing, down from 6.6 times in February, a 73% drop in performance. Meta is addressing these linear scaling limits through its new superintelligence lab and its first model, Muse Spark. Muse Spark spins up multiple AI brains to work on different facets of a task in parallel, stitching the results together. On benchmarks, it scored 4.6 points higher than Claude Opus on visual tasks and beat GPT by 5.4 on health metrics. Parallel architectures provide a more sustainable way to solve complex problems, while individual model reliability fluctuates. AI is moving into the background of existing software. Claude is now in a native beta integration within Microsoft Word, accessible to 1.2 billion users. It can analyze a 100-page contract, flag deal breakers, and apply tracked redline edits directly inside the Word document. For custom workflows, Anthropic's Mule-managed agents automate back-end infrastructure, handling memory, file storage, and retry loops for small teams. To address Claude's memory issues, OpenAI founding member Andrej Karpathy has open-sourced a fix using permanent external storage. This diagram shows how the system connects separate research papers into a navigable web of knowledge, allowing an AI to reference your entire library of past research. Similarly, Cursor's mobile app allows developers to use their phones to trigger remote code fixes on their laptops from anywhere. Professional productivity is shifting toward the oversight of these automated tools and the management of persistent AI infrastructure. AI is also learning to simulate physical realities. Netflix researchers recently unveiled Void, a model capable of physics-aware video editing. Unlike simple pixel tainting, Void understands object interactions. If a heavy weight is removed, a pillow on screen will realistically decompress and rise. Google Gemini has also added interactive physics simulations for technical study directly within its chat interface. While these simulations run in the cloud, specialized military AI operates at the edge. The CIA utilized a tool called Ghost Murmur to track a pilot's heartbeat electromagnetically from miles away. At the opposite extreme, Google's Gemma 4 can now run locally on a laptop, providing offline security and eliminating subscription costs. AI deployment is splitting into 2 worlds: heavy compute spatial simulations and private offline edge computing. This chart shows the scale of the infrastructure war. Anthropic's 2027 power station deal is nearly twice the size of OpenAI's entire current global capacity. While performance benchmarks capture headlines, the race for superintelligence will be determined by physical power and the strength of multi-agent workflows.